Hello students, I hope you're doing well. I'm going to stand behind the camera I think for most of this one and hold the tripod, so it may be a little shaky. But let's take a look. We are talking about this electronics in a nutshell, and I wanted to go over quickly about series parallel, and troubleshooting. So this is part 2. So let's first talk about a series circuit. Okay, this is a circuit where there is only one path for current to flow. If you look at the bottom, there's a schematic down there of 3 resistors, R1, R2, R3. And there's a loop there, there's a square. If you look at that square, and my current leaves the bottom of my power supply. You see where it says 6 volts there? That's my power supply. Yeah, on the left there where it says 6 volts, that's applied voltage. And then I have 3 resistors that are worth 1 ohm, 2 ohm, and 3 ohm, okay? And you can see that if one of my, the current flows in a loop. It flows from the bottom part of the power supply to through R3 and then R2 and then R1 back to the top. So there's some characteristics we need to know about a series circuit, and some of those characteristics are that current is constant or the same. That means whatever current goes through R1 goes through R2 goes through R3. The total resistance in a series-only circuit or a series circuit is going to be the summation of those resistors all added up together, R1 plus R2 plus R3 in this case. And then total resistance is equal to the sum of the voltage drops. And then power is just the total consumption or the total conversion of that. So I used the total power used. So whatever R1 plus R2 plus R3 uses, that is my total power. So let's take a look at the circuit. We're going to do a little bit of math here. We're using that my applied voltage is 6 volts. You look down here at the numbers. I have 6 volts applied. I'm calculating my total resistance of the 3 resistors that are added up. So 1 plus 2 plus 3 is 6 ohms. And then I'm calculating amps. That's my A there for amps. And amps is equal to my total voltage. That's at VT divided by RT divided by total resistance. Let me change the sign here. I got a wrong sign. Where it says VA, it should say V ohms. And whoops, sorry about that. If I can get my tripod set where I want it, we'll be in good shape. There we go. So let me do a quick correction here while I'm looking at it. So this amp right here is so this is my voltage divided by my resistance. So I had 6 ohms, and 6 divided by 6 is 1. So I have 1 amp going through each one of these. So now I want to calculate the individual voltage drops on the resistor 1, 2, and 3. And if I look at those 3 equations on the bottom, VR1 is equal to 1 amp times 1 ohm, and that's 1 volt. VR2 is equal to 1 amp times 2 ohms, and that's 2 volts. And VR3 is equal to 1 amp times 3 ohms, which is 3 volts. And if I add 1 plus 2 plus 3, I get my total applied voltage, which is 6 volts. So that in a nutshell is a quick look at series circuits. Let's move on to parallel and see what's a little bit different there. In a parallel circuit, we're going to look at that, and I've drawn the circuit at the top here. This is the parallel circuit that we're looking at. And I use the same 3 resistors and the same applied voltage here. And what we need to know about voltage is going to be constant here. As you can see, is the top of the power supply and the bottom of the power supply are across each one of these resistors. So here's my 6 volts, and there's R1, R2, R3. So if I were to measure voltage here, 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 I'd measure 6 volts. It's the same 6 volts. It's not additional power supply, so the most voltage I have applied in this circuit is 6 volts. So what we say about parallel circuits is that in this case, voltage is constant, and the current is the sum of the individual branch currents. And total resistance can be calculated by taking the applied voltage divided by the total current. And power is again equal to the total power used. So each one of those resistors, whatever it uses, we add up, and the power company is going to charge us for that. So at the bottom here is I've shown how to measure the individual branch currents. That's what I've shown here. And I've simply taken 6 volts divided by 1 ohm to get 6 amps through R1. And then through R2 is going to be 6 volts divided by 2 ohms, and that's going to be 3 amps. And then the current through R3 is going to be 6 volts to about 3 ohms, and that's going to be 2 amps. And if I add 6 plus 3 plus 2, I get to 11 amps. I use the symbol I instead of the unit of measure A to represent current. So sometimes we'll use VIR for voltage, current, resistance, and power. Or sometimes I'll use the unit of measure, which is volts, amps, ohms, and watts. And if I add those up, I get 11 amps. And so I'm getting the total resistance is a little bit above half an ohm. So let's take a little quick look at troubleshooting. And what I've done is I want to talk about in the context of light bulbs. So let's look at this top one here. This top one here is a series circuit, and as you can see is that when I have a series circuit, those little symbols, little funny things with circles around them, those are light bulbs. So I related it to Christmas light bulbs. When I was a kid, you could buy a stringer of lights, and they were wired in series. So if one of the bulbs went out, all of them went out, and you could not tell which bulb went out. So what did you do? You painstakingly replaced every one of those bulbs until the lights came back on. So that's how we troubleshot back in the day. You could take a voltmeter and measure across each one of those light bulbs, and the light bulb that measures voltage is where my open is, okay? So that's how you'd look at a series when there's an open in a series and the light bulb is not working. You can measure those light bulbs to see if there's any resistance, or measure voltage drops across those light bulbs, and you could tell. Now what they've done nowadays is that they have a combination of series parallel, and we'll look at one of those in just a second. But this is a parallel only circuit, so you could take your light bulbs and wire them in parallel, and the light bulb that goes out is the one that's bad, so you just replace that. So parallel is like your when you're having a power strip on that you're using underneath your desk to plug all your components in, that's wired in parallel. Those are parallel, so that's what happens here. So if my light bulb goes away or goes bad, then my other 2 light bulbs still are shining, okay? And now let's take it as a series parallel circuit. So I could have a series parallel circuit where I've got 3 light bulbs, and if the first one that's in series, which is I have the big X through at the top there, if that first one goes out, then no current flows and none of the other light bulbs get power, so there's no light in that one. If I take a different configuration and I have the light bulb at the bottom is in series with the 2 in parallel, is one of the parallel branches goes out, the current will still flow in the light bulb that's in series, and the other light bulb that's in parallel and still good, current will flow through there and those lights will come on. So that's sort of a quick overview. And to think about this class again is if I were to do a quick seminar, I would probably spend the first hour of this class is if I were to come do some corporate training or do a seminar for a couple of days, this is what I would do in that seminar. Is I would spend the first hour just talking about, hey, here's an overview of the class, here's a roadmap, here's where we're going. There's going to be some more in-depth videos and in-depth laboratories that we do in order for you to understand what you're doing, how to do it, and what does it mean. And so that's what I would spend time doing, and just wanted to give you a big overview so you could take a step back and seeing what we're going to be doing this semester. So this is pretty much it. We're going to be looking at doing the things we started with. We're going to be looking at powers of 10. We're going to be looking at technical notation. We're going to be looking at color code, and then we'll look at Ohm's law and Watt's law. We'll take some time to specifically look at specific circuit configurations, and those circuit configurations are going to be series, and then we'll look at a parallel, and then we'll look at series parallel, and each one of those, inside each one of those individual configurations, we'll look at troubleshooting in each one of those. And so that's pretty much going to take us through the rest of the semester. So we won't go as fast as we did today, but I wanted you to get a good overview. So if you know some of this stuff or want to go ahead and read, make sure you go to allaboutscircuits.com and just look at the specific thing we're looking at in the table of contents under the education tab of that website. And that'll be a good start as far as your reading material, what you need to be understanding and looking at. So look forward to seeing you in class, and I hope you're doing well. Take care, and we'll see you soon.